Welcome. This course compares prompt engineering and loop engineering. On one side, a single prompt. On the other, an automated feedback loop. Prompt engineering means crafting a clear text prompt for a single-turn AI operation. One request, one response. Visually, a prompt feeds into the model and immediately returns a finished answer. One request leads to one response. Loop engineering adds automation. The AI output is evaluated. Then feedback is sent back into a new prompt, again and again. Think of prompting like a director giving an actor a clear instruction for a single scene. Looping is like automated quality assurance. Test the output, refine it, and repeat until it meets the standard. In a human-in-the-loop setup, a person notices mistakes and manually retypes a better prompt. In a computer-in-the-loop setup, a program catches errors and reprompts the model automatically. Section 1 takeaways. Prompting targets single inputs, looping automates multi-step cycles, and loops reduce manual reprompting. Pause for a moment. Prompting is one request and one reply, while looping adds automated feedback. Now try the quick check for this section. Quick check after Section 1. What is the primary focus of prompt engineering? Choose A, B, C, or D. Take 1 minute to think, then choose A, B, C, or D. The correct answer is not shown. Section 2 focuses on prompt engineering techniques, role, context, instruction, and output format. Zero-shot prompting sends a direct instruction with no examples. Few-shot prompting includes a few input-output examples before the main question. Chain-of-thought prompting includes a few input-output examples before the main question. Role prompting assigns a persona, such as a senior data scientist, which steers tone and depth. Delimiters and format constraints, like triple quotes or JSON schemas, keep inputs and outputs structured. Negative prompting states what not to do, such as avoiding jargon or speculation. Single prompts have limits. Packing a complex task into one giant instruction often causes confusion and failure. Section 2 takeaways. Structure prompts carefully. Use chain of thought for hard logic. And remember that single prompts have limits. Pause here. Strong prompts use role, task, and format, and chain of thought helps hard reasoning. Now the quick check for this section. Quick check after Section 2. Which technique asks the model to think step by step? Choose A, B, C, or D. Take 1 minute to think. Then choose A, B, C, or D. The correct answer is not shown. Section 3 covers loop engineering and feedback systems that keep improving outputs automatically. The generator-evaluator pattern uses one model to create content and another to check it against rules. Step 1, the model drafts code, and that draft enters a sandbox for testing. Step 2. Tests run and fail. For example, an index error appears as a clear alert. Step 3. The error log is formatted into a new prompt and sent back to the model automatically. Step 4. The model corrects the code, tests pass, and the result is approved. Always set a max iteration limit, such as 5 attempts, to prevent infinite loops. State persistent stores loop variables so each iteration remembers what already happened. Section 3 takeaways: combine generation with testing, self-correct from feedback, and bound iterations for safety. Pause here. Loops generate, test, and feed errors back, with max iterations for safety. Now the quick check. Quick check after Section 3. What is the main purpose of an evaluator node in a loop? Choose A, B, C, or D. Take 1 minute to think, then choose A, B, C, or D. The correct answer is not shown. Section 4 introduces autonomous agents and React architecture, where models use external tools. React means reason, act, and observe in a continuous cycle. In the reason stage, the agent breaks a goal, like planning travel, into tactical subtasks. In the act stage, the agent calls a tool, such as a weather search API, to fetch live data. In the observe stage, tool results return into context and trigger the next reasoning step. Across loops, the agent picks tools dynamically: web search, SQL, or a calculator. In multi-agent systems, an orchestrator assigns work to specialist agents, such as research, writing, and review. Guardrails block unsafe actions, such as dangerous system commands, while loops keep running.
Section 4 takeaways. React enables tools, agents cycle through reason, act, observe, and multi-agent loops tackle complex projects.
Pause here. React is reason, act, observe, with tools and guardrails. Now the quick check. Quick check after Section 4. What 3 steps form the React agent loop? Choose A, B, C, or D. Take 1 minute to think, then choose A, B, C, or D. The correct answer is not shown. Section 5 compares architectural trade-offs between prompting and looping: speed, cost, and quality. Latency rises with loops. A single prompt may return in 1 second, while a 5-step loop may take about 12. Token cost also grows. One turn may use a few hundred tokens, while loops can consume thousands across iterations. Quality often improves with loops. A single prompt might reach about 70% accuracy, while self-correcting loops can approach 95%. For simple tasks like summarization and basic Q&A, prompt engineering is usually enough. For complex work like software development or research reports, loop engineering is the better fit. A hybrid approach uses well-engineered prompts as nodes inside a larger loop pipeline. Production loops need dashboards that monitor tokens, errors, and time to completion.
Section 5 takeaways. Prompts are fast and cheap. Loops trade latency and cost for accuracy, and hybrids often win.
Pause here. Prompts are fast, loops raise accuracy, and complexity guides the choice. Now the quick check. Quick check after Section 5. What is a key trade-off when switching from prompting to looping? Choose A, B, C, or D. Take 1 minute to think. Then choose A, B, C, or D. The correct answer is not shown. Section 6 covers real-world applications and best practices across code, finance, support, and writing. In software development, loops run unit tests and refactor code until the build passes. In customer support, prompt engineering can answer common FAQs instantly in live chat. In finance, loops can ingest reports, query databases, verify math, and produce audited summaries. Best Practice 1. Start with strong prompt engineering before building complex loops. Best Practice 2. Always define fallbacks and human escalation paths inside automated loops. Best Practice 3. Log all intermediate loop states for debugging and audit compliance. The modern AI stack combines LLM providers, prompt management platforms, and loop orchestration frameworks. Section 6 takeaways. Match the pattern to the need. Always include fallbacks and limits, and master both prompting and looping. Pause here. Match prompting or looping to the job, and always keep fallbacks and limits. Now the final section check. Quick check after Section 6. What should you do before building complex automated loops? Choose A, B, C, or D. Take 1 minute to think, then choose A, B, C, or D. The correct answer is not shown. You have completed a quick check after each section. You can now explain prompting, looping, and when to use each. Congratulations! You completed Prompt Engineering versus Loop Engineering. Thanks for watching.